Hello friends, welcome to my channel. Today we'll make a 12 volts UPS battery tester, and we'll start from this laptop battery tester. Now let's begin. So, first of all, I have to thanks to Open Green Energy, this one from laptop. It's made from his blog. Now let's test this laptop battery tester. As you can see, here is the voltage, the current and the capacity of this battery, and will take about 10 hours to test the full capacity of this battery. Now let's talk about the new tester for 12 volts battery. We will make some changes from this original schematic. First of all, we don't need this mini USB port for supply the microcontroller, because we'll use the voltage from this battery that we'll test, and we'll use some step down module like this, and from 12 volts input we'll make 5 volts for this microcontroller. Instead of this big power resistor, we'll use a lamp, auto lamp like this. Here is an IRFL with logic input. We can use a standard MOSFET. We don't need this one with logic, because we'll have 12 volts from this battery to command this MOSFET. We'll also use an OLED screen like this, and all the parts are here prepared. What I have to tell you is that if we measure the resistance of this lamp when it's cold, will show us 1.5 ohms, but when we will put it on power supply, it shows 12 volts, 5 amps, and with ohm low we can calculate the resistance of this lamp, and the resistance is approximately 2.4 ohms. We can also will modify in this soft, we'll modify the thresholds for on, off and high voltage, low voltage, high voltage. Now let's start. So the PCB is ready. I've put all the wires from the schematic. You will have the schematic in the description and the soft. So in that time that I was put the parts here, I realized that this will not work in that configuration that I projected first time, and I will explain you why. This is original kit for laptop batteries. This is a logical level MOSFET that needs only 5 volts to the gate to be closed. But in this configuration for laptop battery, I want to put a normal MOSFET with 10 volts voltage for grid, because this MOSFET has better parameters than that MOSFET. This one logic level MOSFET works only to 40 amps, and this normal MOSFET works until 100 amps. And this kit I want to use also on small UPS batteries, and also I want to use to a big UPS batteries, 100 amps hour or a car battery. And that's why, to not wait a long time, this load can be small value, so we'll decrease the time of this measurement. Now, for the first time I will power this kit. Just now I put the soft here, but the soft is not adjusted for what we need. I just modified the thresholds for this one, so we'll check. I will show you what will happen when we put this on 5 volt. First of all, I have to put here the volt. This is a step down from 12 volts to 5 volts. I have to make this adjustment, and I will power this from 5 volts, because if you will watch the schematic you will understand better. In initial configuration, I think that if I replace that logic level MOSFET with normal MOSFET, usual MOSFET, it will be enough to put a pull-up resistor from gate to plus 12 volts, and this will pull up the input voltage of this MOSFET. But then I realized that this digital D2 pin, when he has to open this MOSFET, will put to the ground and will work. But we want to close this MOSFET. This digital pin will give us only 5 volts, and the pull-up resistor to the plus will not be able to pull up the voltage, because every digital output of an Arduino has a protection diode to limit the voltage under and over his input voltage, supply voltage, and that's why digital output cannot give us more than 5 volts plus 0.6 volts, and this voltage will be not enough to close this MOSFET. And that's now I have two options. Option number one is to replace this MOSFET, normal MOSFET, with logical MOSFET. But I don't want to use this because, as I said, this normal MOSFET has 100 amps. And that's why first of all we'll make some tests, and after I will modify the schematic of this, so we'll take out the command from this Arduino, and with one transistor we'll be able to command this MOSFET. Now let's make the first test. We'll put the power supply to the 5 volts. So, as you can see, I use a color code. Red wires for plus, black wires for ground, and gray and blue for data wires. Now I will have to use only 5 volts because I forgot to adjust this before I put this. And if I use 12 volts, it's possible that will give us 9 volts and will burn the Arduino. And that's why I have to use only 5 volts. So let's check. The voltage. It seems that it's working. As you can see. So, current voltage, let's see why. So, we have 5 volts input, it's okay. We have here 5 volts input. It's okay. We have output of the step down. It's 4.4. Let's adjust. As you can see, gives us only maximum 4.7, because I presume that's the maximum that this step down module can give us on 5 volts. So if we want more, I will limit this. And I will increase the voltage from here to 6 volts. we have to adjust this to exactly 5 volts because these 5 volts will be used as a reference to all the other voltages. So we have exactly 5 volts. As you see, it's working, but the voltage that is shown here, it's not accurate because I did not put the good values of this resistor in the soft. Now I will show you why this is not working in this configuration. So here is ground, here is plus. So ground, here is plus 6 volts. Here is ground. Now it's working, but just because we have here a small current. I will show you that if I will put a bigger load, smaller resistance, this MOSFET will not be able to put the output to the ground. So it's only 9 millivolts. 0.9 millivolts is good. So this is ground. This is the output. This is the input voltage, the gate. It's 5 volts, as I presume. Now we can increase the voltage because I adjust the step down. This screen, it will indicate this voltage, but now it's not indicated the good voltage because of this voltage divider. It's not set on the software, but this adjustment will made only later. Now let's increase the voltage to 12 volts. High voltage. Let's check. The supply voltage for Arduino is good, but this alarm, it's because the threshold in the software. Now I will have to modify the threshold in the soft so I can show you why it will not work now. So I adjust in the software the threshold for on and off and the voltage, this voltage divider. And now let's check. 10 volts. This is not working well. I have to check the voltage divider and so I have to check this voltage divider and the threshold value in the soft, because this should disconnect at 11.9 volts. Let's check this. It's only a small difference. As you can see, at 12 volts it disconnects. So it's a 1 volt difference, and I have so this voltage should be the real voltage on input, but as you can see, there is 1 volt difference between a real voltage so real input voltage is 12.7 volts. This shows us only 11.9 volts. I have to check the soft, and the values of this divider gives 1 volt difference. Now let's see if I was right. This is not warm. The current should be good, 47 milliamps, and now it's starting this cycle for capacity. As you can see, milliamps hour is the capacity, and it's increasing. Now let's see if I was right. So here is ground, here is plus 12.7 volts. It's okay. Now, as you can see here on the other side of the resistor, it's good. It's only 2 millivolts. It seems that this MOSFET, it's a logic level MOSFET. But what we can do, we'll change this load and we'll put a small resistance low, small value resistor that will give us a big current. And let's see if this MOSFET can handle a bigger. that's good. This resistor is warm. The MOSFET is not warm. But for high current I will have to put aluminium on this MOSFET, so will not warm. So it seems that I am lucky because I just checked this MOSFET on Google and it's a logic level MOSFET. I took it from a bad UPS and I believe that there's not a logic. And now if this is logic, I don't have to change this input voltage. It's working from 2 to 4 volts and Arduino it's enough to close this MOSFET. Now I put this heat sink on the MOSFET and let's make some test, but with more power. Now I've replaced the load, this load, with auto lamp, and as you can see it's something is not good, because as you can see it turns on and off. This shows low voltage. We have 12 volts. Now let's see why. When the current is high, so first of all let's check the supply voltage. There is a drop voltage of 1 volt when the lamp is on and off, and I presume that when the lamp is on, the voltage decrease under the low threshold. Now let's check. Because of the resistance of the wires. Now let's increase the input voltage. And as I said, when I increase the input voltage, it's not going low under the low threshold. Now let's check the voltage. So input voltage is 30.6 volts here, and in power supply we have 14, more than 14 volts, and there is a drop of voltage on these wires that are not good for this current that we have here. We have more than 5 amps. Now let's see if the heatsink is not hot, has only 25 degrees, 30 degrees. That means that we can put a small one. Or better, I still use this because in the future I want to put 2 lamps on the output, on the load, so we'll have a smaller time to check the big batteries. So MOSFET, it's not warm, it's not very warm. MOSFET, it's okay. With these wires I can put another load because the drop of voltage will be too high. Now let's check the difference between the current here. It's not good because I have to declare the good values of this voltage divider in soft for Arduino. So only thing that I have to do now is recalculate this voltage divider and declare the value of for load, and will indicate the good power. Now let's see the difference between voltage show on the screen and voltage, real voltage. So real voltage is 13.6, and these show us only 12.6. Now let's check the voltage divider. Ground. Okay, middle of the divider, and input of the divider. I will have to write this down because these resistors are not small tolerance, and there is a 10% difference between value written and the real value, and that's why I will write down the voltages here, but it's better to do this without load because load it's floating the result. So I take down the load. Ouch! It's hot. It's very hot. So I rewrite the software to correct the voltage divider and this load. Now let's check this, if it's good now. So put this. This. So that's good. Now here is high voltage. The high threshold I put 40 volts and here is 40.3. Now let's decrease. It seems that it's good because let's check the voltage. It shows 30.39 and here there is a small difference. Now let's check the step down. And now we'll make a trick. But before that, I will have to rewrite. So here we have $30.2, here 4.10, so this is the trick. I will decrease the voltage from this step down, and this will decrease the voltage, and we have to align this voltage with this voltage, but this works only under 5 volts. We can put voltage, supply voltage under 5 volts. It's not recommended to increase above 5 volts. We can do this only under 5 volts. And you will see if I change this, let's check this. Shot. That's not good. So I decreased the voltage, supply voltage for the Arduino. And now it seems like I have to increase the supply voltage if I decrease the supply voltage, so the supply voltage is used as a fixed reference for this. So I made a short circuit here. I hope that I not burn the Arduino. And I hope that I burn only this step down module. So let's decrease. It seems like that, unfortunately for me, I made here a short circuit. This gives an overvoltage to the Arduino, and this old Arduino now it's working, but I cannot reprogram this because this serial interface, USB serial interface, is broken, and I am sure that it's broken because when I touch this, it's very warm. If I put to the power supply, it's very warm. So this old Arduino is broken. I replace it with another one. I put the new version of the software, and now let's see. Let's turn on 12 volts. Now let's check. We'll take the ground from here to not make another short circuit, and I will use only this plug. So what we have here, input voltage, low voltage here. Let's increase the input voltage. So we have 12.1 and here 12.1. So don't need another adjustment. That's perfect. As you can see, 12 volts, 0.07, 12.06. That's perfect now. Now that remains, as you can see here, shows the current, because the current it's not measured on a shunt resistor. The current is calculated input voltage over value of the load resistor. And now I will have to check again the software and see why it's not showing the good current. Let's check again. We put the load. We have to increase the input voltage to compensate the loss on the cables. So power supply shows us that we have 5 amps, and here show 2.7 amps. Now I will check the software and I will come back. So I simplified the code, I removed some lines, and now, as you can see, the current indication is good. It says 500 milliamps. So the voltage is good. Let's check the voltage. We have, I forgot to put a ground. So voltage indication is perfect. Current indication is good. Even we don't have the load, Arduino thinks that we have 2.4 ohms load, and that's why shows this value. Now I will have to make the final changes, and I will change these values from milliamps to amps, and capacity from milliamps hour to amps hour, because that's best for this 7 amps hour, or car battery, or solar panel battery that have 100 amps hour. So I will have the final changes now in the software. So here we are for the final test. I repaired the software. Now the software is good. I replaced that heatsink, old heatsink, with one smaller, because old one was too big, was not necessary. Now let's make the final test. I will put this UPS battery, but it's not fully charged, because if it's fully charged, will take about 1 hour or 2 hours to discharge completely. Now let's connect the battery. After test, the lamp is on. We have here the voltage 12.1 volt. Second line is time in hours, and the last line is amp on hour capacity. As you see, the voltage drops, and when the voltage will reach the lower threshold, it's 11.8 volts. Then the cycle will stop, probably in 1 or 2 minutes, and will print low voltage, and underneath capacity in amps hour. Until now, as you can see, it's 0.1 amp hour, and time will in hours. 0.1 hour, it's 6 minutes, I think. It's decreasing slow, as you can see. I want to tell you that you have to take care, because as you see, I burned Arduino Nano because I was not careful and put a bigger voltage on the power supply. I will put all the schematics. You will have the schematics, the software, and the PCB design in the description of this video. What we can do, let's replace this battery because it will take too long. Let's replace the battery. Heatsink, it's not very hot. Let's see, I hope this is not fully charged. As you can see, this one was not fully charged, and voltage without load voltage is 12.2 volts, but with the load voltage drops under the low threshold, and that's why the lamp is off. If I will let this probably 1 or 2 minutes, the voltage will blink about 1 minute, and after 1 minute the voltage will drop under the low threshold and will not be on again. As you can see, when This is the end of the cycle, low voltage and capacity 0.1 at this battery, but was not fully charged, was for test. As you can see, the voltage drops 12.2, 12.1, 12.08, and about 1 minute will be definitely under the low threshold and the lamp will not be on again. After this project I intend to do a more simpler kit for this without Arduino, just very simple for beginners, so they can test batteries like this. And if you want, I can do a second version of this one with lower time. This needs 1 or 2 hours, this, but we can do a new version with a smaller time. Approximately in 5 minutes we'll test the battery. Will not be a full test, just will not be a full test, will be a speed test. As you can see, the voltage continue to drop. Now it's 11.8. .85. Soon will not be able to turn on the lamp. I hope that you find this project helpful. Please like and subscribe to support this channel, and see you in next video. Thanks for watching. Bye.